Hi, this is Ingwon Lee, and our team member is Hogo New and Jongho Kan and Seungho Jung. Our project's name is Zero-Shot Learning for Spoken Language Understanding Systems for Low-Resource Languages. Let's start the presentation. As the AI system evolves, spoken dialogue systems are commonly integrating to our life. In the spoken dialogue systems, there is a problem that currently spoken dialogue systems are available only in limited languages. Major bottleneck is low-resource languages. Local and unwritten languages is the lack of availability and annotated data in these languages. There are some kinds of previous works about this problem. The first is using phonetic transcription instead of text. The second is end-to-end pipeline. The second one is impossible to low-resource languages because it needs a lot of data to train. Our task is Spoken Language Understanding task. This task is classifying the spoken utterances intent. For example, when the speech "bring the newspaper" is come, our model classifies its intent. We use two kinds of data sets. The first is FSC data sets, which consists of English, and it's a huge data set. And the second is global data sets, which consists of Belgian and Dutch. It's a little bit small data set. The data set statistic is in the slide. We build a low resource setting to limit the speaker and utterance. We adapt zero-shot learning to our model. We first transform the support set and the query set to pawn list used Allosaurus, and our embedding network embedded each utterances. And we calculate average embedding between the same class in the support set. Finally, we can get predictions or training loss using distance between support sets embeddings and query sets embedding. We use FSC dataset to meta-training, and we test on each of FSC and global dataset. When we test on FSC dataset, we definitely separate the data by intent. This is our experiment results. The baseline model is not used zero-shot learning, and the below two table is our proposed results. The left one is training with four-way one-shot learning. The right one is training with four-way two-shot learning. And we do not fine-tuning to our task because it is a zero-shot learning. As can be seen from the table, we show similar or better performance to the baseline model even without fine-tuning. Especially more extremely low resource setting, our model shows about 10% to 20% accuracy improvements. This is our conclusions. We propose a new method of zero-shot learning for the spoken language understanding task. The spoken language understanding problem was solved by applying zero-shot learning to extreme low resources. We achieved higher performance than the baseline performance. Our future work the first is, until the final report, we will also check performance experiments on global dataset. And second is apply various meta-learning methods. This is our presentation, and thank you for listening.